Welcome to The Explainer. Today, we're unpacking something absolutely fascinating, how modern researchers have finally solved the incredibly complex geometry of Erwin Schrödinger's color theory. We're going to break down exactly how this historic discovery radically modernizes our understanding of science, light, and honestly, reality itself.
100. That is exactly how many years this massive puzzle regarding how humans actually perceive color has completely baffled some of the greatest scientific minds on the planet. I mean, we're talking a full century of guessing, crunching numbers, and ultimately just hitting mathematical dead ends.
Okay, let's dive into this. When you look up and see the brilliant blue of the sky, or maybe the deep, vibrant red of an apple, you probably assume that color is, just a subjective trick of the brain, right? Like it's purely a human experience. Well, get ready to have that fundamental assumption totally challenged, because the latest geometry says something entirely different.
Section 1, a century-old scientific puzzle. So our journey actually starts with Erwin Schrödinger, and yeah, you probably know him best for that famous cat-in-the-box quantum physics experiment. But exactly a century ago, he proposed this highly complex theory to mathematically map human color perception inside a three-dimensional space. And the wild part? The scientific community has literally been relying on this legendary, yet mathematically incomplete theory ever since.
Section 2. The flawed Riemannian model. Now, to really grasp this breakthrough, we first need to understand something called the neutral axis. You can basically think of it as the grayscale backbone of the entire color system, the line moving straight from black to white. For decades, under those traditional models, this absolutely crucial center point of the foundation remained mathematically incomplete. Past scientists simply couldn't define it properly.
Now, what's really interesting about this slide is the hard, undeniable truth that held science back for so long. The traditional Riemannian model was fundamentally flawed. It basically assumed that human eyes measure color differences in a straightforward linear way. It's like we were trying to measure a curve with a completely straight ruler. It totally failed to accurately map how our eyes actually process color.
Section 3. The non-Riemannian breakthrough.
And this brilliantly illustrates the night and day difference between these two mathematical approaches. We're finally tossing out that old, flawed Riemannian model. By adopting an entirely new, non-Riemannian spatial framework, we suddenly have a highly accurate model, one that mathematically defines color difference, explaining precisely how our eyes measure the gaps and shifts between colors.
So, who are the modern heroes of this story? Well, it's the researchers over at the Los Alamos National Laboratory. By completely throwing out the old assumptions and applying some seriously advanced geometry, they managed to crack the code that had stumped the scientific community for 100 years. They successfully defined that tricky neutral axis mathematically, once and for all. So the crucial point is that color intensity and hue are intrinsic properties of the color system itself. Guys, this is a massive paradigm shift. By proving this through pure geometry, the researchers showed that color isn't merely some subjective human experience or illusion. It is a hard, objective property baked right into the mathematical fabric of light.
Let's move to Section 4 and see how this builds into revolutionizing future imaging technology.
Because we finally possess an accurate mathematical foundation for color, we are going to see some truly revolutionary improvements across massive industries. This doesn't just modernize theoretical science, right? It brings profound, real-world upgrades to things like data visualization and imaging technology. Just imagine medical scans becoming infinitely more precise, or scientific models suddenly revealing hidden patterns that we just couldn't accurately map before.
Think about it. Our entire digital reality, from our computer monitors and televisions right down to our smartphones, relies on rendering color accurately. Now that the Los Alamos researchers have finally solved Schrödinger's 100-year-old puzzle, the future of how we visually interact with the world is about to change forever. Which leaves us with a pretty provocative thought to ponder. How exactly will this new mathematical foundation change the screens you look at every single day?